Hey, this is 11.2 gas pressure, and your goals are to describe the units of measurement used for pressure and change from one unit of pressure to another. This is a barometer used to measure pressure. It's old school because it has mercury in it, which we can no longer have because it's toxic. What happens in these things is you have all your gas particles in the air flying around really quickly because they're not attracted to each other and they have infinite space. So when they hit the surface of this mercury, it puts pressure on it and it pushes the atoms that are in this liquid. It causes them to go up this tube. So it should make sense that the higher the pressure pushing down on it, the farther distance it will move up the tube. And we measure those in millimeters of mercury. Hg is the symbol for mercury. And then millimeter, if you remember, is just 1/1000th of a meter. So that's what's happening there. And of course, in the United States, we're going to do inches of mercury because people don't like metric system for whatever reason. Where it says vacuum, no air particles, that's important because the liquid has to be able to go up into the tube. If there was air up in there, it wouldn't be able to, or it would have resistance. Pressure is force divided by area. It should make sense later on that if you decrease the area, you get more force. But the force in this case is the actual molecules hitting the tubes or the sides of the container. And then the area would just be the size of the container. Measure pressure here, so as the pressure increases, it would move up. Again, this is just a barometer. You've got your liquid mercury. Your molecules push down and cause this to go up your tube. That's how we measure it. Just random thought. When you drink out of a straw, you're not actually sucking that liquid up the straw. What happens when you drink out of a straw is you remove the air molecules off the top, so the air molecules outside of your drink push your drink up into your mouth. So it's actually the air pressure pushing drink in your mouth, not you pulling it in. I didn't know that until I started teaching chemistry. These are units for gas pressure. This is atmosphere, ATM. My favorite because it's a 1. 1 atmosphere is equal to 760 millimeters of mercury. So 1 atmosphere of pressure, that mercury would move up 760 millimeters. And also 760 torr, which is another unit for pressure named after a science person. 1 millimeter mercury is equal to 1 torr. In SI units, pressure is measured in pascals. 1 atmosphere is equal to 1.01325 times 10 to the 5th pascals, or 101.325 kilopascals. So that K means kilo, which means 1,000 times a pascal. So those are the same as these ones. So that's just your kilo telling us that we have 1,000 pascals. When we do ideal gas laws, you have to pay attention to which unit of pressure you have because you'll use a different gas constant. If this seems confusing, it's basically the same thing. You're just talking about units that are interchangeable for the same amount. So like if you have $1, that's the same as 20 nickels, 4 quarters, 10 dimes. Those are all equivalent. So when things are equal, that means that we can express them in terms of the other unit. So saying that, you know that $1 equals 4 quarters for sure. It's the same here. So if you can think of it like that, all you're doing is just changing what we're calling it. So here's a table that you need to know. Screenshot it, put it somewhere, or just know that it's here. It's also on formula sheets if we were at real school. So these are all the same ones we just discussed. Their abbreviation, so like here, that means pounds per square inch. And then PSI, if you've ever heard that. Matters when you're putting air in tires. It turns out if you get distracted and keep putting them in there, they pop. just so you know. It's really loud too. Altitude affects atmospheric pressure. So when you're higher at sea level, which is 0 kilometers, atmospheric pressure would be 760 millimeters of mercury, or 1 atmosphere. If you are like lazy math. Los Angeles, the altitude is 0.09 kilometers, and the atmospheric pressure, as you can see, didn't change very much. But when you go up high, 4.5 kilometers, the atmospheric pressure decreases to 440. And the reason why, from the videos before, is you have less particles over you. Pretend you're the container. You have less particles putting that force on you. I tried to look up Huntsville. I found our altitude is 0.195 kilometers, but the atmospheric pressure, I was going to convert it, and actually I got distracted and forgot. Learning check. Let's change 475 millimeters of mercury into atmospheres. First, you have to know your conversion factors, which is not money, so not bad. So you've got to know this to change those. So before we can do this problem, we have to know our conversion factor, and that means you have to know that 1 atmosphere is equal to 760 millimeters of mercury. It's the same as always. You take your given 475 millimeters of mercury and you multiply it by the ratio that cancels out the units that you're converting. So 760 millimeters of mercury in 1 atmosphere, which basically means that you're dividing 475 by 760, and that turns out to be 0.625 atmospheres. Millimeters of mercury have canceled, and now we're happy. There it is, topped if you like that better. The pressure in a tire is 2 atmospheres. What is this pressure in millimeters of mercury? Just go in the opposite way. Still, 1 atmosphere equals 760 millimeters of mercury. Start with your given. Multiply by your conversion factor that cancels atmospheres. Now we're canceling 760 multiplied by 2 is 1520 millimeters of mercury. Super yay! Hope this is helpful. I try to clear out all the words on the slides and make it a little more visual. Just type it into the stream if you have any questions. Have a great day.